Hello and welcome to this R tutorial. So we just trained our artificial neural network on the training set, and now time to make the predictions on the test set. So lucky for us, we already have everything ready here thanks to our classification template that we pasted in the first tutorial. So actually this section predicts the test set results and this section makes the confusion matrix, thanks to which we will obtain the accuracy on the test set, that is some accuracy on new observations on which our artificial neural network model wasn't trained. So first, let's take care of this section and let's see what we need to change. So first of all, this first line gets the predicted probabilities thanks to this predict function, but that was the predict function used for built-in R packages. But here, since we are using the H2O package that is kind of special, there are actually some things that we need to change here, but a very few things. So first, as for all the functions we used with this H2O package, well, you notice that when we use a function, we first take the H2O package, then a dot, and then the name of the function. Well, we need to do the same here for the predict function. So here we just need to add H2O dot predict. Okay, so that's the first thing we need to change. And then let's see. Let's go inside the function. So the first argument is classifier. Let's press here F1 to get some information about the predict function of the H2O model. So let's scroll down to have a look at the arguments and let's see what they are. So as we can see, we have only two main arguments and then some additional arguments, but that we will not focus on. Instead, we will focus on the two main arguments here, which are the object and new data. So the first thing we can see is that there is no type argument. So here simply we will remove this type equals response argument and input because we actually don't need it. All right, and now we are left with the two arguments we are required to input. That is the object, which is our classifier here. That is the ANN model itself that we have just built on the training set. And then the second argument, new data. And this new data argument is expecting, of course, the observations of which it has to make the predictions. All right, so that's exactly our test set. And here we remove the dependent variable column thanks to this -3 here. But we need to replace this 3 because this number 3 here corresponds to the index of the dependent variable of the data set that we worked with in part 3 classification. And here, of course, the index of our dependent variable is not 3, but is 11. Remember, we already replaced the index 3 here in this feature scaling part. So we replaced the 4 indexes 3 that were here by 11. And so here we need to do the same. We will replace this 3 index here by index 11. All right, so now this is taking the test set observations as new data. That is, it will predict the probabilities that the dependent variable exited equals 1 for the observations in the test set. And therefore, it will predict for each customer in the test set the probability that this customer leaves the bank. And since we have the real results of whether the customers of the test set left or stayed in the bank, well, we will compare our predictions to these real results, these actual results, and that's how we'll get the accuracy by computing the number of correct predictions divided by the total number of observations in the test set, that is 2000. And then, if we get a good accuracy, then maybe we'll get a good and powerful model, and if that's the case, we will give it to the bank on a plate and tell the bank, okay, now you can rank all the customers in the bank by their probability to leave the bank. That is, for each of your customers, you can predict with a good accuracy, and we'll be able to tell them precisely what this accuracy is. You'll be able to predict with a good accuracy the probability that the customer leaves the bank. And then you can add, therefore I can give you a ranking of all your customers ranked by their probability to leave the bank from the highest probability to the lowest probability. And therefore you can do some customer segmentation and consider, for example, the top 10% probabilities that the customers leave the bank. And in this segment, you can analyze deeper the factors that lead the customers to leave the bank by using some data mining techniques, like, for example, doing a chi-square test or applying the stat summary function on your independent variables to understand which independent variables have the most impact on the dependent variable. That is, which independent variable explains the most why customers are leaving. Well, you know how to do that. That's exactly what we did in part 2 and 3 when we used this summary function to get the p-values and statistical significance levels to see which independent variables are the most statistically significant and therefore explain the best the dependent variable, that is why customers are leaving. So that's the purpose behind making these predictions on the test set. It's just to get the accuracy on new observations, to validate the model, so that we can give this model to the bank. Alright, so now let's make the predictions. So we are almost done here. We just need to add one more thing, which is again related to the fact that we are using the H2O package. And as you can see in this new data argument, well, this new data is of course the test set, but this test set is expected to be an H2O frame. Right now it is a standard data frame, but our H2O predict function is expecting an H2O frame. So how can we convert this test set data frame into an H2O frame? Well, by doing exactly the same as what we did to convert this training set data frame into this H2O frame, that is by applying on the test set the as.h2o function. Alright, so I'm putting the test set in the function like that, and here we go. Now I think everything is ready. We are ready to make the predictions, which so far will be the prediction of the probabilities that the class equals 1, that is the probabilities that the customers leave the bank. So let's select this and get the predicted probabilities. And here we go. We now have the prob-pred vector containing all the predicted probabilities in the form of an environment. So that's good, but we cannot have a look at these predicted probabilities yet. We will need to convert it back into a standard vector. But before we do that, convert it into a vector, well, we need to apply this line as well, which will, transform the probabilities into the predictions in the form 1 or 0. That is exactly the predictions of the dependent variable exited. And to do this, we're using this if-else function, and basically what we do is we choose a threshold such that if the predicted probability is above the threshold, then we predict 1, and if the predicted probability is below the threshold, then we predict 0. So that's a natural threshold to take when we get our predictions in terms of probabilities. Know that it is not necessarily always 50%, 0.5. That's the case, for example, in medicine when we have to predict some sensitive informations, like for example, predicting if a tumor is malignant. Well, that's more sensitive. So in that case, we'd better be sure of our predictions, and therefore we would choose a higher threshold, like for example, 80%. But here we are predicting if a customer leaves the bank, so we are fine with a 50% threshold. So that's okay. And by the way, there is a more simple way to get these predictions in the form 0 or 1 without using this if-else function. It's by simply removing this 1 and 0 here and removing this if-else, and by using this prob-pred larger than 0.5, because this will return a boolean which will be true if prob-pred is larger than 0.5 and false if prob-pred is below 0.5. And y-pred in the form of these booleans true and false will be accepted in this confusion matrix here. So that's more simple, and now let's get these predictions in the form of booleans. Alright, so I'm going to select this line and execute. Alright, so now we have our y-pred in the form of booleans, but it is still an H2O object because it is the result in the first place of this H2O.predict function. So it is still an H2O object, and therefore now what we have to do is to convert this H2O object back into a vector, because this table function here will only accept a vector, a standard vector, and of course will never accept this H2O object. So let's convert it back into a vector, and that's actually really simple. It's actually kind of the same as converting a data frame into an H2O frame, but instead of using H2O here, we will use vector. So here we simply need to type ypred equals as dot vector, and in parentheses, of course, ypred. Alright, so let's check it out. I'm going to select this line and execute. And now, as you can see, ypred became this vector of integers containing 2000 elements, and that's the standard vector of R we were used to working with. So we can actually have a look at the predictions of the test set observations by typing here in the console ypred. Here we go, that's all the predictions of the test set observations, 2000 predictions. So here we go, according to the model, the first customer stayed in the bank, the second customer stayed in the bank, the third customer left the bank, the fourth one stayed, the fifth one stayed, etc. So if you want, you can actually compare these predictions with the real results that are in the last column of test set, this column here. So for example, 0, 0, 1, 0, 0, 0 are the real outcomes of the fifth first customers. And if we compare that with the predictions, well, we see that the predictions are quite correct, because here we get as well 0, 0, 1, 0, 0, 0. So the 5 first predictions are correct. So that smells pretty good for our accuracy that we're about to compute, because when we look at the first observations, we can only see correct predictions. So now, actually, I can't wait to see the accuracy. So let's compute it right now. We will start by making the confusion matrix. And of course, here we need to replace this index 3 here by 11, because this corresponds to the index of the dependent variable. And so now we're ready to make this confusion matrix. So I'm going to select this line and execute. Here we go, confusion matrix created. So now let's have a look. I'm going to type CM here in the console and press enter. That's our confusion matrix. We can see a lot of correct predictions, so that's good. 1,536 correct predictions of customers who stayed in the bank and 195 correct predictions of customers who left the bank. And then we have 212 plus 57 incorrect predictions of customers who either left or stayed in the bank. So this looks pretty good. And now let's not wait anymore. Let's compute the accuracy. So the accuracy is the total number of correct predictions, that is 105,036 plus 195 divided by the total number of observations in the test set, that is the total number of predictions actually, which is 2,000. All right, so let's check it out. Let's see if we can offer this model to the bank. Let's see if we'll get the bonus. Let's find out about this accuracy on 3, 2, 1, go. 86.5%. That's actually not bad at all. 86.5%, well, let's say 87. 87% means that on 100 observations, 87 predictions should be correct. So this is pretty good. And besides, we haven't done any parameter tuning. And you will see that by doing some parameter tuning, using some techniques like k-fold cross-validation, well, we can get an even better accuracy score. No worries, we will do that in part 10. You can actually already practice to improve this accuracy score. And please let me know if you get an awesome one. And now, just one last thing. Since we were connected to this H2O instance, it's better to disconnect from it now. And to do this, we only need to apply a last function of H2O, which is the H2O.shutdown. Here it is, with no arguments inside. You just need to select this, and this will disconnect you from the server. So let's execute. Are you sure you want to shut down the H2O instance running at this address? Then you just need to type here capital Y and then enter. And now we're disconnected. True means yes, we did disconnect. So congratulations, you have built your first artificial neural network on R using the H2O package. I was very happy to build this first deep learning model with you, and we are getting to the end of this section. Next section will be about convolutional neural networks, another branch of machine learning specialized for computer vision, because it will consider spatial structure in the data, exactly as it is the case for images, where the position of the pixels matters. So we will see that in the next section, and until then, enjoy machine learning!